Hi, welcome back to the channel. Here is a part 2 of the previous video. So let's just get right into it. Now now we are looking at the second problem. Okay, so we have our function y as secant theta. Okay, and the question is, we need to show that the second derivative of this function with respect to theta must be equal to 2y times 2y squared minus 1. Now, which means that all we need to do is to find the second derivative of this function and then simplify it in this format. All right, so let's do that. Now, we basically know that what dy dy theta is just derivative of secant theta, which is just what? Secant theta tan theta. I mean, this is a basic function. You should know how to find the derivative of that. And it's just secant theta tan theta. Now, what about the second derivative of this? Okay, how do we find this? Now, the second derivative of this function is basically the derivative of the first derivative. So it means d theta of the first derivative, dy d theta. So which means we need to find the derivative with respect to theta of this function, secant theta tan theta. Now, this is quite easy for most people to do now because we see that when you have derivative of product of two functions, we know how to deal with that. It's just basically the product rule, right? Because we have product of secant theta and tan theta. All you need to do is substitute a variable for this and a variable for this. And it becomes clear that you have to find the derivative of the product of two functions. So where the first function is secant theta and the second function is tan theta. And we know the answer to this. The answer to this is what? We leave u, then find the derivative with respect to the second function, plus we leave v, multiply that with the derivative with respect to the first function. Okay, so let's find, so all we need to do is to find du d theta. Now, what is du d theta here? Derivative of secant theta again, which is what? Secant theta tan theta. Then we have the derivative of v with respect to theta, derivative of tan theta, which is just secant square theta. All right, now that we have this, let's bring it back to this, this level, okay? So which means the second derivative with respect to theta is just gonna give us, remember, u dv plus v du. So what is u? Don't forget u is secant theta, times dv, what is dv? Secant square theta, plus v, what is v? Which is tan theta, multiplied by derivative of u with respect to theta, which is what? Secant theta tan theta. Right, don't forget, this is your du d theta. All right. Okay, now that we have this, all we need to do now is to simplify and then finish the problem. So this gives us secant cube theta, right, plus tan square theta multiplied by secant theta. Now, remember that what? Secant theta is y from the problem, right? Secant theta is y. So if you substitute that, so that will give us y cubed plus y times tan square theta. Now, all we need to do now is to write this tan square theta in terms of y. Now, don't forget this, your identity, that 1 plus tan square theta equal to secant square theta. So this gives us that what? Tan square theta must be equal to secant square theta minus 1. Now, what is secant square theta? That is just, remember secant theta is y, so that will be y squared minus 1. So basically, we can finish the problem by writing y multiplied by what? Y squared minus 1, okay? Because tan square theta is y squared minus 1. And this would give us, when we expand, y cubed minus y, sorry, here is cube. So y cubed minus y. So when you add this together, that is 2y cubed minus y. And then you can factorize y is common. So factorize y out. What is left is 2y squared minus 1. So cool. So this is how we solve this problem. All right. So that will be the end of the video. Make sure you like this video if you enjoy it, as well as subscribe to the channel to help the growth of this channel. And then I'll see you in the third part of this particular problem set.